Okay, ladies and gentlemen, welcome back to Math 30-2, Chapter 7, Lesson 1, Characteristics of Logarithmic Functions with Base 10 and Base E, Part 2. Now, here, I need you to take the x-intercept, the number of y-intercepts, the end behavior, the domain, and the range of the following functions. Y equals 15 log x. Now, use the equation of the function to make predictions. Verify your predictions using the graphic calculator. So graph the damn thing. Now I know I said graph it afterwards, but graph at the beginning so you know what the answers are. Now, pause the recording, graph the darn thing, then come back and we'll talk about it. Alright, welcome back. Now, as I was saying earlier, I want you to realize that the log is the opposite of an exponent. It's actually a different way you write the exponent. So if you have a log, so if you have a exponent function like the red one here, you can get to hazard a good guess what the log function looks like. So in that here, I want you to realize the exponent function will look like this. This line, we will get a log. Something like that. Now, the x-intercept here on the log function, there's one of them. Notice there's one y-intercept on the original, but that's x equals 1. Now, how many times does the log function cross the y-axis? Here's the log function here. It doesn't cross the y-axis. Just like the exponent didn't cross the x, so no. The end behavior. Well, on the left side, will be down. The right side will be up, eventually. Our log graph of the red one is going to the right, it is going up slowly. Now, that leads us to the domain. Here, notice it doesn't cross the y-axis, so it's always x is greater than 0. Where have we seen something like that before? Yes. The range of the exponent. And if you think back to the exponent, the domain there is x is all real. That will yield, the opposite of that will be the range here. Range y is all real. Okay. So it's basically the opposite of the inverse, the opposite of the exponent function. And I'm really hoping I got that right. This is very embarrassing when I screw up something like that on video like this. Okay? Now, let's try this one here. Take the x-intercept, the number of y-intercepts, the end behavior, the domain, and the range of the following function. Y equals minus 4 ln of x. And you're going, oh, what the heck? Oh, minus 4 times log base e of x. We're having trouble with that. Okay, now this one here has me confused because I got the minus sign there. Standard log, the standard exponent goes like that. So your standard log goes like that. So the minus sign is screwing everything up. Okay? Now that minus sign actually means that your graph is being flipped. Now that's a little bit sneaky, a little bit evil, which is why I'm doing this with you. So actually, the graph goes like that. It's flipped upside down. Now, that's why I said, please, graph the damn thing first, even though I said graph it after. No, graph it now. But I want you to notice the x-intercept is 1 at 1, comma 0. Number of y-intercepts, there's going to be none. The end behavior, left up, right down. Now, that one's a little confusing, but remember, plus x squared versus minus x squared becomes the opposite. This is the exact same thing. Now, the domain, our x values, x is greater than 0, and the range, y is all real. You should be able to get that from the equation without graphing it. But yes, graph the third thing. Okay. Now, which function matches each graph below? Now here, what are we doing? Okay. Now notice we've got 4 different versions of Now, we just did, make that, we just did minus, and we showed how the exponential graph goes backwards. Oh, wait a minute. That's a logarithmic graph. Forgive me. Sorry. Let's do this from the beginning. We have 2 exponent graphs and 2 log graphs. So the first graph here, A is 5, and B is 2. So which one of these looks like an exponential graph? Oh, that looks like an exponential graph, and that looks like an exponential graph. So which one of these has an A value of 5 and a B value that's increasing? B. That's increasing, so B is definitely greater than 1. So this belongs to B. Now, the only other one that looks like an exponent graph is D. Now notice here, A equals 2, and B is a fraction less than 1, so it has to be this. Now, some of you are going to say, but Mr. Sutton, this looks a whole lot like an exponent graph. It does, except an exponent graph doesn't cross the x-axis. So it looked more like that. So this is actually a log graph. That's to confuse you. Now, let's double check. Y equals 6 log x. All right, so this one and this one are both log graphs, but only one of them is increasing, because this one is decreasing. Okay? So far, so good-ish? Okay. Now, if I give you an equation or I give you a graph, you can tell me the domain, the range, the intercepts, is the function increasing or decreasing? Now, the one thing we haven't talked about, and it's a homework question, is for y equals 3 log base 10 of x, so now, this is additional notes, but I realized this is similar to the homework questions, or sorry, the classwork questions. What's x when y is 200? We've done stuff like this before. I just want to hit on it, or do one with you, just make certain you remember. So y equals here, here. Now, I just said 3 log base 10 of x, so putting that in your graphing calculator, that is 3 log of x. Now remember, base 10 by definition, we don't, it's, sorry, try that again. We don't have to say it because it's by default. What is it, 200? Yes. So we graph this. I expect you to be able to graph it. And there we go. Now, what about my windows? Okay, well, the problem is I screwed up my windows. Negative 10 to 10. Reset your windows. Always, please, ladies and gentlemen. And And there we go. So there is my log function. Where is my other line? 200. Well, 200, y equals 200 is way up there. So window, $210, 10, graph. They're there. Now, I can tell right off the bat this is a huge horrible number. Window 0 to 10,000. And there's 1,000. Oh, not even close. Window. Oh, I'm up to billions and it's not there yet. Anyway, you get the idea. You have to make your windows really big. 1 e to the 30. Oh, I'm up to the hundreds of billions. Getting there. Now, it's 1 exponent to the 99. Second, calculate, intersect, enter. Yes. 4.68. Okay. Okay. Now that's 4.68 times 10 to something, and it won't show me what it is because it's being hooted. Which means I gotta redo the video. Anyway, get the idea, change your windows, find where they intersect. Got any questions, shoot me an email, otherwise good luck. Good luck.